learning the theoretical side of quantum computing is easy. There's courses out there all over the internet about quantum algorithms, quantum information processing, Dirac notation, everything you need to understand the theory of quantum computation. However, learning about the hardware side of quantum computing is much, much more difficult. There's very little resources out there at the moment, and QuantumEDGE Academy aims to fill that gap. So QuantumEDGE Academy is a suite of courses designed to teach you everything you need to know about the hardware side of quantum computing to get started to make measurements in a cryogenic quantum laboratory. So we have two suites of courses. We have what we call in the applied quantum computing courses. The idea behind these is they give you an introduction to the hardware infrastructure in a cryogenic quantum computing lab. So that's, for example, the dilution refrigerator, the hardware measurement apparatus. And what do you need to understand to make measurements with these instruments? And then we have the superconducting quantum computing courses, and these take you through the process of calibrating and tuning a superconducting qubit. Now, all these courses are developed very much with practical quantum computing in mind. So what do you need to know to actually practically perform measurements in a quantum computing laboratory? Okay, so here we can see our Making Your First Measurement course. So the idea behind this course, it guides the student through making a measurement of an RLC circuit that's situated inside a dilution refrigerator. So that at the end of the course, they'll do a practical assessment on a simulated environment where they'll make this measurement. And throughout the course, they'll be guided through the various knowledge and information they need to make this measurement. So for example, they'll learn about complex impedance, they'll learn about electrical resonators, they have an introduction to signal processing. So they will learn, for example, about time and frequency domains. They will learn about the various components that they'll be using to make the measurements, such as mixers. They'll be learning about frequency modulation, so up conversion and down conversion, IQ demodulation, everything that a student will need to perform a measurement in a quantum laboratory. And now at the end of this, they will take a practical assessment. And the idea behind this practical assessment is the student will have to use the knowledge and understanding they've gained throughout the course to make a measurement on a simulated quantum system. But the catch is that this system will be, imagine that it's incorporated into a real laboratory environment. So for example, we can see here that in this practical assessment, the student will make an S21 measurement of an RLC resonator, but the resonator itself is situated inside a dilution refrigerator. So they have to take account of the attenuation of the lines, how much power they're going to send in, the resolution of their measurement, everything they would have to think about when they make this measurement for real in an actual laboratory. The idea being that then when they've they've completed this course, that then they'll have some knowledge and intuition for when they step inside the laboratory, they'll be able to say, there's a dilution refrigerator. What do I need to understand about the way the signal is processed through the fridge in order to make a measurement? What do I need to understand about attenuation? What do I need to understand about the instruments? What's an up conversion? What's a down conversion? By completing this course, they'll have understood all these concepts, so they're ready to make a measurement in a real quantum laboratory.